In the previous two videos, I showed you how you can draw the line of best fit for 3 data points, 1, 2, 3. But in reality, you're going to get lots and lots and lots of data points. So in this video, we're going to look at the algebra behind lots of data points. So, so the first step is to create a new function z, and the idea is to jump to the line, and then take away, well, to extract this difference here, and then square the distance. So that will give you this area here, and we're really trying to so jump to the line and then extract the distance and then square it, So the idea is to minimize the areas of all the rectangles. So we created this function here. Well, I'm expecting you to know this. We've done this in the previous two videos. So the critical point occurs when the partial derivative with respect to m and the partial derivative with respect to b equals 0. So we require that this and this equals 0. So so looking at this, we've got to differentiate it with respect to m. So looking at this, differentiate it with respect to m. So so the 2 is able to come down. So the 2 and the bubble stays intact, and then times the derivative with respect to m. So so when you differentiate this, it would just give you this. So so the derivative is given by this. And even though there's a summation sign here, you can still differentiate it. Let me illustrate why. Hang on. Let me jump to here. So even though there's a summation, here, you can still differentiate it as normal. The 3 is able to come down, and the power of m gets minus by 1. Because if you look at this, this is really saying m to the power of 3. Looking at this, I here, 1, 2, 3, 4, and when you differentiate this, the 3 comes down, the 3 comes down. Well, when you differentiate this, it gives you this. Differentiate this, it will then give you this, it will then give you this, and then if you tidy this up, it will lead you to this. So even though there's a summation here, you can still differentiate it. So let me just jump back to this. So so now looking at our new function here, differentiate it with respect to b. That will then give us this thing here, because imagine this as being a bubble here. The 2 comes down, the bubble stays intact, and then times the derivative of b, which is just 1. So differentiating it will then give you this. So now now hang on. So now I is ticking away. So I is ticking away. This well, 2 is a constant. You can take it out here. So 2 is a constant. You can take it out. This 2 here is a constant. You can take it out. And then so here you've got 2 simultaneous equations. So divide everything by 2. That will then give you. That will then eliminate the 2. And then hang on. So we are currently here, and then divide everything by 2. That will eliminate these 2, and then multiply this out. That will then give you this whole thing here, and then this thing here is this thing here. So again, we've still got 2 simultaneous equations. 1, 2. So now now hang on. So now now let me think. So so you've got 3 blocks here. 1, 2, 3. Add this block to both sides. Add it to the other side. Add this to the other side. So we've got 2 simultaneous equations here. So it's just a matter of eliminating the b. So let's eliminate the b. So hang on. But before we do that, let me explain what is meant by this thing and this thing. So when you look at this here, remember you've got lots of data points. I equals 1, I equals 2. I is ticking away up to n data points. So for the first data point, when I equals 1, look at the first point. So so look at the first point. Extract the x value of the first point. So let's just say this is I equals 1 here. Get this distance here, xi, and then multiply it by y, multiply it by this length here. So that will then give you this area here. So you're summing up all the areas. Look at the second data point. Let's call this I2 here. I equals 2. So here you're looking at the x, extract the x, and multiply it by the y. That will then give you this area here. But then if you look at this, what this is saying is for the first data point, just look at the x only, and then square that length. So that will then give you this area here. So that's the difference. This thing here is looking at this area here. This thing here is looking at the x value here, square it. So it's looking at this area here. So there is a difference between the two. Okay, so currently we are here at the moment. So currently we are here at the moment. So now we want to eliminate the b. So looking at the b here, if we times the first equation, by n, so multiply everything by n, and then later on, for this one here, multiply everything by this thing here. So the second one, multiply everything by this. Well, we're trying to eliminate this b here. So let's start again here. Looking at this, multiply everything by n. So this times n, that will then give us this thing here. This times n, that will then give us this. This times n, that will then give us this. Now looking at this second one, we're trying to eliminate the b here. So multiply everything out by this thing here. So multiply everything out by this thing here. So looking at this times this thing here will then give you this, and then this times this thing here this times this thing here will then give you this, and then this times this thing here will then give you this. Remember, we're trying to eliminate the b, and notice that these two are exactly the same. So we can get equation 4, which is this thing here, get equation 4, take away equation 3. That will eliminate these two. So hang on. So our next step is to get equation 4, take away equation 3. So get this equation, take away this equation here. So remember, these two would disappear later on. So getting 4, take away equation 3 would be this, which is this thing here, take away this thing here. That will then give you this. Remember, these two would cancel each other out. And then get this, which is this thing here, take away this thing here. That will then take us to here. So now it's just a matter of getting m on its own. So m is in common, factor out the m. So factor out the m, that will then give you something like this, and then divide everything by this. So divide everything by that thing there. So this thing here disappears. So m equals this thing here. So now we've got the gradient. The gradient's given by this. Well, hang on, let me think. So we've got m at the moment. If you have m, then you can immediately work out b, because from above, this was our simultaneous equation. So once you've got m here, you can work out b. So take away, looking at this here, take away this thing here. So hang on. So take away this thing here. So that would then be m xi equals 1 n, and then divided by n. So b equals this thing here. So the point here is that we have the ability to work out the gradient, which is m, and we have the ability to work out the intercept, which is b. So we can draw our straight line. So in the next video, I'll give you an example with more than 3 data points. Okay.